Okay, so we're going to go through the Algebra 2 Trigonometry 2012 January Regents. First question, the yearbook staff has designed a survey to learn students' opinions on how the yearbook can be improved for this year. They want to distribute a survey, and which one's going to obtain the most reasonable data? Well, every third student sent to the office, no, that's not random. Every third student entered the library, no. Every third student to enter the gym for the basketball game, no. Every third student arriving at school this morning. Yeah, you want these. This is going to be a random sampling. You don't know what you're going to get when you get every third student sent to the office. They could be there for all different types of business. They might be involved in clubs, sports. Every third student sent to the library, that's just going to be the real studious kids. Every third student go to the basketball game, those are going to be the sports kids. But every third student arriving into the school is a random collection. That's what you're looking for. What's the sum of the first 19 terms of this sequence? First, you got to determine whether it's geometric or arithmetic. It turns out the difference between each term is 7, so it's arithmetic. The 19th term would be 18 of these plus 7s down the road because, here's my first term, and then you would do plus 7 18 more times to get to the 19th term. That's going to be 129, and then just use your reference table. Right on it is the sum of a finite arithmetic series. Just plug in. You want the 19th term, so plug 19 in for n. The first term is 3, and the last term is 129. Divided by 2, boom, 1,254. Which expression, when rounded to 3 decimal places, is equal to this? Honestly, just use your calculator. Enter it right in. Secant is 1 over cos. Cosecant is 1 over sine. And punch it right through. This is a composition problem. Remember to rewrite this from right to left. This is f of g at a half. So g at a half goes inside. Find that first. Plug in a half for g. Turns out g at a half is 2. That means this quantity inside is really 2. Plug that in for f. Boom, 4. Population of rabbits doubles every 60 days. Where p is the population. What's the value of t? Honestly, looking back at this, I think I took the long route by even dividing by 10. You should just plug these numbers right in. You could use logarithms if you really wanted to. I would not recommend it. That's the hard approach to it. Just plug right in. Okay, I divided by 10 just to get 2 by itself, but that really wasn't even needed. 6, you're foiling, double distributing. Got to know how to multiply fractions. Top times top, bottom times bottom. This is also the difference of 2 perfect squares, so you could have just attacked it from that way. Number 7, which the following is the graph of y equals cotan of x. Cotan, remember, is the reciprocal of tan. Just punch it into your calculator. Go look for the answer. Which expression is always equal to 1? Cos squared x plus sine squared x. This is a Pythagorean identity. It is worth your time to remember that. Worth your time. You will definitely get a question about it. What are the sum and product? These are formulas, also worth your time to remember. The sum is always negative b over a, the product is c over a, and then just here's a, there's b, there's c. Plug in. Given this triangle, what type of triangle can be drawn? This is a law of sines problem. First, sketch a diagram, okay? Right? So, you know how much angle B is inside B. You know how much A is. Angle A, you'll figure out using law of sines. If you forgot law of sines, it's on your reference table, right? Oh, look at that. They took it. Oh, no, right there. Right there, right there. There's law of sines. Okay. So, law of sines, cross multiply, divide. I did that real fast. And then you want to find A, which means you got to use the inverse, which means the inverse of all of this business equals A. Plug it into your calculator, you get 58. Now, remember also that the sine of 58 is also equal to the sine of 122 because the sine of supplement angles is always the same. You can check this out. And so you need to check to see if this will also fit into your diagram. It could just be an extra answer, right? There's always 180 degrees to a triangle. If you can fit this angle in, with the angle they gave you given, there's more than one triangle, right? One, two, or or none at all. This is the ambiguous case of sines. Anyways, 122 is just way too big. I mean, it puts us over. We got 70 degrees already in there. That's 192. Reject this, which means there's only one type of triangle that can be formed using these measurements, and it's acute. This is just a fancy way of saying the reciprocal of x. Boom. Put it in there. We're going to try and clear them out by using a fancy technique of clearing the denominators, this guy right here. So I'm going to multiply by x over 1, both of them. Distribute that in there. You get x plus 1. So you get x plus 1. Some people might get confused. They'd say, like, well, where'd you get this x plus 1 business? When you distribute it inside, right? X over 1 times 1 over x is just, they cancel, that produces 1. X over 1 times 1 is x, and then you can just rotate it around. I just rotated it around so that it would match the bottoms, and you could easily see how things would cancel. All right? So know that, all right? If the amount of time students work in any given week is normally distributed with a mean of 10 hours per week, standard deviation of 2. So here's the important thing, right? Here's our mean. That goes in the middle of our bell curve. The reason I knew to use a bell curve is because it says it's normally distributed. Mean of 10 in the middle. Standard deviation of 2. What's the probability that a student works between 8 and 11 hours? Well, 8 is one standard deviation away because it's 2 units from 10. 11 is a half a standard deviation away. And then you just add up the percents. Where did I get those percents from? Right here, right? You are adding one standard deviation away plus another half, right? That's these. That's 15, 19.1, and 19.1 right there. What's the conjugate? This is a vocab. All you do is switch the sign in the middle. That's the conjugate. Given angle A in quadrant 1 with sine A, 12 over 13, and angle B in quadrant 2, with cos equal to negative 3/5. What's the value of cos A minus B? So if you look up in the reference table, this cos A minus B is right up over here, cos A minus B. Right? Remember to look there and write that down. So you'll notice that you're missing some things, right? We don't know what the sine of B is. We don't know what the cos of A is. Draw these triangles, right? Sine of A in quadrant 1. Use Pythagorean theorem. Sine is opposite over hypotenuse, right? 13 squared minus 12 squared, square rooted is 5. And cos of B adjacent, that's where I got that negative from, negative 3 over hypotenuse 5. Use Pythagorean theorem, you get a 4. It's 4 because it's positive up in the y direction. And then you automatically can know now sine of B and cos of A. And just plug them in, right? Top times bottom times bottom. Add them, you get 33 over 65. Which expression represents the third term of this expansion? If you forget how to expand things, the formula is on your reference table right here. You just need to know how to read it, right? So you could expand it out. I started doing 3C0, 3C1, 3C2. This is my third term. 3C2, 2x to the fourth, raised to the first power, negative y raised to the second. Once again, all of this just comes from this formula right here. Just plug into it, one by one. I didn't feel like listing them out because it was extra information. 3C2 you plug into your calculator is 3. 2x to the fourth raised to the first power is just itself, and negative y squared is y squared. There you go. That's it right there. What's the solution set? Well, you could plug in these problems one by one, or factor, right? These guys' greatest common factor is the GCF is 3x. You're left with x to the fourth minus 16. This is the difference of two perfect squares. This is the difference of two perfect squares again. And then solve. Find out what value makes them all 0. 0, negative 2, 2. And this is imaginary, so it's going to be plus or minus 2i. Sequence has the following terms. All you're going to do is punch in and find which one of these formulas creates this sequence. The first term, the second term, the third term. You punch it in, 1 in for n, and then 2 in for n, and then 3 in for n, and find out which one gives you these exactly. We want to find out what's the area of a triangle BLF. Sketch a diagram. Here's my parallelogram, right? How do you find the area of a triangle? Well, using trigonometry, what we're going to do is we're going to divide our parallelogram in half. This is from the reference sheet right up over here. 1/2 AB sine C. That's 1/2 AB, the two sides, and the angle in between. Now, some people are going to say, like, okay, where did I get these from? You got to know properties of a parallelogram. Opposite sides are congruent. Opposite angles are congruent. Which statement about this graph is not true? Just graph it in your calculator, honestly. That's the easiest way to do it. What's the number of degrees in an angle whose measure is 2 radians? To convert from radians to degrees, multiply by 180 over pi and reduce. Remember, degrees to radians, pi over 180, if you were going the other way. Spinners divided into equal sections. 5 sections are red, 3 are green. Spinner spun exactly. If a spinner is spun 3 times, what's the probability that it lands on red exactly twice? This is a probability problem using combinations. So 3 times, you want 2 of them. Probability of success is 5/8, and we want 2 of them. Probability of failure is 3/8, and we want 1 of them. What's the range? What is the range of this? Let's just use our calculator. Let me show you how to do that. So we're going to punch in to the y equals screen. Remember, in the math section is where we're going to find the absolute value of x minus 3. Close it up. Plus 2. Hit the graph button. The range are all the y values, and y has to be greater than 2. Boom, all of this. Anything greater than 2, we get some, that's where this thing exists. Which calculator output shows the strongest linear relationship? For strength of a linear relationship, all you're doing is looking at the r's and find out which one is closest to 1 or -1. This is an extremely strong negative linear relationship. 24, I'm going to be honest with you, 24 I think is the single hardest problem on this whole multiple choice section. First, add log 2a to the other side. Try and get log x by itself. Right? Condense these down. When you're adding 2 logs with the same base, you multiply their results. That's these inside. That's 6a squared. Exponents come down in front. That's 2 log x. Now I'm trying to make this, my answer, look like whatever I got over here. And what I'm seeing is a bunch of 6's and a's. So I'm going to split this back up even after I multiplied it, right? Split it back up into log 6 plus log a squared. This squared comes down in front. Boom, because exponents pop down and multiply. Divide everything through by 2, and you get this answer. Once again, very difficult problem, very difficult. Which function is 1-to-1? Use your calculator to be 1-to-1. You got to pass the vertical and horizontal line test. If p varies inversely, there's the key word. That means that p times q equals k, a constant. P is 10 when q is 3/2. The first thing you got to do is figure out k. Multiply these two, figure out k. K is 15. What's the value of p when q is 3/5? Well, it's never going to change that k is never going to change. So p times 3/5 equals 15. Divide both sides by 3/5, you get 25. Which equation is graphed in the diagram below? Well, let's try and use our test-taking strategies. This is an inverted cos graph. So that means a in front has to be negative. Cross this out, cross this out. Let's find the period. Period is 2 pi over b. It took 30 units for us to see one complete cos graph. Cross multiply, solve, b is going to be pi over 15. There's my b right there. That's it. On to the short answers. The short answers. All right. So find the solution of this inequality. Set it equal to 0. Okay. Find our critical values. Set it equal to 0. Solve it. That means -1 and 5 are our critical values. And test points to the left, in the middle, and to the right. If they work, that's where we're shading. That's where our solution sets are. That's our answer. Solve algebraically. What are we going to do? We're going to subtract 4 to the other side, divide by a negative, square both sides, get it all by itself, right? And then finally you get x equals 7. Now you always need to test your answers when you have radicals because you could get nothing as your answer. 2 times 7 is 14. 14 minus 5 is 9. Square root of 9 is 3. 4 minus 3 is 1. We're good. Here, you're just plugging in integral values from 1 to 3 into here and adding them together. It's a summation. Expressed in simplest form, this is the cubed root. Raise everything in here. Oh, I mean, just take the cubed root. What multiplied by itself 3 times is this quantity? The blood bank needs 20 people. 25 people have volunteered. How many different groups? Order doesn't matter. It's a combination problem. You got 25 people volunteering. They need only 20, so it's 25 C20. This one, use your calculator. Honestly, that's a piece of cake problem. Just plug in. Here's my table of values out of my calculator. Write an equation of the circle in the diagram. Well, I took a cheap shortcut. What you really need is the center. You need the radius, I'm sorry. I used Pythagorean theorem, right? Here's my diagonal. There's my radius. That means that this leg is worth 2. This leg is worth 3. Use Pythagorean theorem. The radius is squared is 13. And remember, the equation for a circle is x minus h squared plus y minus k squared equals r squared. Our r squared is 13. It goes right here. Our x-coordinate, our h, is -5. So x minus -5 is x plus 5. Y minus k, y minus 2. There we go, right there. That's our equation for a circle. Express the exact value of cos 60 with a rational denominator. Well, cos 60, I'm sorry, of cosecant 60. Cosecant, I always remember this as no two cos go together, right? Cosecant goes with sine. 1 over the sine of 60, plug the sine of 60 into your calculator. You gotta remember this. Turn my calculator on, make sure it's in degree mode. I'll show you something, right? This is super important. The sine of 60 degrees is, you must commit this to memory, 0.866 is rad 3 over 2. 1 divided by rad 3 over 2, that's keep, change, flip. Boom. How do you rationalize denominators? You multiply by itself, the radical. There's your answer. 36, here's our diagram. Now, I'm looking at 3 triangles. This triangle, and the big one. We need the height of the tower, all right? So here's what I'm going to do. First, it's really suspicious that they gave me information, a lot of information about this triangle right here. I got 32 degrees, okay? I got 100 feet. And I'm trying to see how I can make sense of this. The problem is that I've got a whole bunch of angles missing. Whole bunch. Well, that's where these other angles come in, right? Here's my big triangle. 90, 32, 65. That means this must be 115, okay? If this is 65 and this is 90, that's 25. And now that I know that this is 90 and this is 32, it means this total angle up over here, this guy must be 33. Well, what am I going to do? I am going to use the law of sines to try and figure out this hypotenuse right here, okay, from this triangle. So I say to myself, the sine of 33 degrees, okay, 100 over the sine of 33 equals x over the sine of 115. Cross multiply, solve, I get that x is 166. Now, I'm not rounding, by the way, not rounding. Then, now that I know that this is 166, I'm just going to use simple trig. The sine of 32 equals the opposite side, the tower, over my hypotenuse. Boom. Cross multiply, solve, you get 88 feet. Logs. Remember, logs. Here's our triangle right here, the Bermuda Triangle, the base, the result, the exponent. That's how I teach it in my class, because logs are always confusing and we always get lost in the Bermuda Triangle. So base, result, exponent, which means if we convert back into logarithmic form, into exponential form, 4 raised to the 2.5 power is x. That's 32. Same thing over here, okay, except that you get that y. It's the -3/2 power equals 125. We need to raise both sides to the reciprocal to try and get y by itself. You get that y is 0.04. 32 divided by 0.04 is 800, because we were ultimately wanted x over y. Here we're just going to use our calculator to do an exponential regression. Type all of this into your calculator into the L1. Type all of this into the L2. Maybe I should show you how to do this. Let's do this one together because my class got this one wrong. Okay, we're going to go to Stat, Edit. We're going to punch this all into our list. Okay, and then into our L2. Sorry about that. There you go. And then we want to go to Stat, make a calculation. We want an exponential regression. Exponential regression with L1, comma, L2. Hit enter. Okay, and there we go. I just rounded them. Raise to the x power. Using this equation, predict the number of single-celled organisms to the nearest whole number at the end of the 18th hour. You just plug 18 in for x, get your answer and round. Piece of cake. 39. 39. Okay, let me zoom out a little bit. This ultimately is an organization problem. Beyond all the factoring that we're going to have to do, you need to efficiently find a way to organize all this information so it doesn't become too overwhelming. And that's what I'm doing on this left side over here. I'm taking each one of these items and I'm factoring it so I don't get lost. This is factoring by grouping, okay? Right? These guys both have x squared in common. Pull it out. These guys both have 6. You get the same items in parentheses. This and this go together in one of them. This comes down with one of them. And that's factor by grouping. Greatest common factor of these guys is x, x minus 4. Greatest common factor of this one is 2, and it's x minus 2. Greatest common factor of this one is x cubed, it's x minus 3. Over here, this is a normal factoring problem. Find two things that multiply to be negative 8, but add to be 2. And this is the difference of two squares. Sub them all back in. It's division, so you're going to do keep, change, flip. That's why I flipped this up over there in its factored form. And then cross cancel. Remember that x minus 4 and 4 minus x cancel out to be negative 1. X minus 3's cancel. X minus 2's cancel. And these cancel out to be 1. So look what you're left with. Just this. And you could simplify it to that. And there you go. That's the entire January 2012 Regents for Algebra 2 Trig.